Hello everyone, this is Priyanshu Choubey, Assistant Professor of Suresh and Bihar University. Today we will going to talk about the flame photometer, flame emissions spectrophotometer and their principles types of flame photometers and how to handle it, operation of a flame photometer, advantages of instrument. So let's and precautions also. So let's see what is a flame photometer. Flame photometer, flame emission spectrometer. Atomic emission spectrometer using a flame photometer has been extensively used for the estimation of the alkali metal. Alkali metal means like sodium and potassium, and alkaline earth metal. Alkaline earth metal means calcium, magnesium. In soil plants and water samples, the precisions, precisions and accuracy for sodium and potassium determination using a flame photometer are better than those for calcium and magnesium. The use of an improved burner systems, high dispersion monochromators, and nitrous oxide acetylene flame, and markedly improved the performance of this technique by improving precisions and the detection limit capability for many other elements, while at the same time managing minimizing certain types of interference. The development of double AS and ICP AES instruments, despite their higher cost, have completely replaced a flame photometer in many laboratories in the advanced countries, but flame photometry has advantages of the comparatively much less initial and maintenance running cost because of its simple optical system, and the operation procedure are well suited to the laboratories that cannot afford costly equipments. Um, Principle of flame photometer. So when a solution of a salt is sprayed into a flame, and salt break into the component atoms due to high temperature, the energy provided by the flame excites the orbital electrons to high energy level. When these electrons return to their ground state, they emit a characteristic radiation. Flame emission spectrometers are designed to measure the intensity of the characteristic line uh, emitted from the excited atoms or the ions of the element to be determined as opposed to AAS, which involves measurement of the absorption of radiant energy by excited atoms. Rich 1965 he gave. Each excited individual atoms emits one quantum of the radiation when it returns to the ground state. Therefore, the increase in the intensity of radiation emitted from the and the non-luminous flame will be proportional to the number of atoms of the particular elements in the flame. Is that its concentration? This concentration is directly related to the content of the element in the test solution. Like most of the analytical techniques, this method it's also not absolute from a comparative and concentration of the analyte in the sample is to be computed from the calibration curve. The instrumental setup consists of three parts. First one is a atomizations assembly and compressing nebulizer to produce a fine mist from the solution and a burner which vaporizes the analyte. Mm, Second one is monochromation system filter prism that separate out the analytical wavelength from the other radiation. Photometric system of measuring the intensity of the emitted radiation. Types of flame photometer. So flame photometer are two types: single beam and double beam. Single beam types are single beam equipments commonly referred to as a direct reading type, compress only a one set of optical light emitted from the core of the flame just above the inner cone is collected by a reflector uh, and focused by a lens of heat resistance glass through a interchangeable optical filter. Interface type filter on the single photo detector. Alternatively, light from the burner passes into the monochromators and radiation leaving the exit silt is focused on to be a photo detector only. And second one is double beam types. Double beam types in the double beam types instrument a second light path is provided for the radiation emitted by the internal standard element, mm, example lithium, that is added in the fixed amount to each test solution as well the as calibration standard. The wavelength of internal standard and the analytical material are isolated by mean of spatial filter in dual optical system, and each beam is focused on a separate photoelectric cell. The various types of flame photometer available commercially are classified into four main categories: direct, reading, absorption, filter barrier layer cell. Coleman Evans electroselenum, also called double EL, Croning models 2 or and 3, Sucknest and Stronic, also called ILI Co. Internal standard interference filter barriers layer cell analytical instrument Baird model KY second synthesis Jack Land model 4 and Neroloco uh, Patwin Brickley Prism chromato direct reading of recording photo multi per tube And fifth one is a grading monochromator recording to photo multiple tubes. Operation of flame photometer. Operation of flame photometer. While the ordinary types of manual flame photometer can be operated with a great easy, modern flame photometer are operated with the help of computer software and necessary operational parameters and can be set through a keyboard command. The actual steps involved may vary with the type of the instrument. Therefore, the users are advised to consult the manual provided by the manufacturer. However, the common step required are first one is the select the desired optical filter. First one, the select the desired optical filters like potassium, sodium, and calcium. Switch on the instrument. Switch on the compressor to get air supply. Adjust the air control knob to give a pressure and prescribed in the operation manual. Leave the instrument for the about 5 minutes to get stabilizing. Turn on the gas supply and uh, light on flame. Adjust the gas control until formation of separate stable color cones in the flame without a sound. Set the galvanometer to zero by the control knob against the reagent blank solution medium. Set the galvanometer to 100 with the highest concentration of standard solution. Repeat the two last step till the above setting the obtained without further adjustment. Proceed with the determination of the remaining standards and sample. For switching off the instrument, close the glass. Supply first run distilled water for about 2 minutes more and then switch off the compressor. Turn off all the knob and switches. Precautions. Precaution. Keep the standard and sample free from any suspended material to prevent collaging of the nebulizer and the capillary. Do not feed highly concentrated acid and salt solution. Maintain a constant supply of air gas mixture to the burner. Do not leave the flame unattended. Periodically replace the pressure tubing of the fuel gas. Advanced instruments, atomic absorption spectrophotometer, Advanced instruments atomic absorption spectrophotometer principle in the analysis employing atomic absorption spectrometer AAS the sample in in the form of the homogeneous liquid in the aspirated into a flame where free atoms of the element to be analyzed are created. A light source halo cathode lamp is used to excite the free atoms from in the flame by the absorption of the electromagnetic radiation. The decrease in energy absorption is then measured with the follows the Lambert-Beer law. The absorption of proportional to the number of free atoms in the ground state. Most of the leading instruments manufacturers have launched tandem models of AAS with the interchangeable flame and uh, graphite funerals version. The graphite funerals has had advantages of analyzing large number of elements, including mercury and arsenic and selenium with greater precision up to part per billion level with the help of online dilution and the calibration in the fully PC based models. The sample throughput has increased tremendously while minimizing the human error of various steps. Preparation of the standard and sample solutions. Prepare stock standards in concentration of 1000 ml per liter from a pure metal wire granules, foil, metal oxide, or other suitable compounds of the elements and given make the sample solution free from interfering elements and suspended solid and the may causes a collaging of the nebulizer adjust both standards just unknown to concentration range which compatible with the analytical range of the instrument. Operational step of AA check for the proper fitting of all the tubings and connections, required type of burner, air acetylene or nitrous oxide and acetylene halocathode lamp, etc. Fill the liquid trap with the solvent used for the analysis. Alight the halocathode lamp of the element to be analyzed with the optical path of the instrument by routing the lamp turret. Switch on the instrument and allow the list 30 minutes for a warm up. Switch on the Switch on the deuterium lamp for a background correction, which is generally required when the wavelength of the resonance line of the element is less than the 250 nm. Use lamp current recommended by the lamp manufacturer. Select the desirable wavelength and the band pass with or silt with. Optimize burner position by using vertical, horizontal, and rotational adjustment knob until the burner slot is elegant with the beam and just below the position from where it's start blocking the light path. Switch on the compressor to get air supply in case of air and acetylene flame. If mm, nitrous oxide acetylene flame is used, turn on the nitrous oxide acetylene supply cylinder. Select air with the support sector knob. Adjust the support for a air reading between 6 and 10 flow unit. If nitrous oxide acetylene flame is used, first ignite an air acetylene flame and then change over to a nitrous oxide acetylene flame. Turn on the main gas supply from the cylinder, followed by a fuel control knob of the instrumental and light and the flame immediately. Adjust the fuel control acetylene and support control air or nitrous oxide knob to produce a required kind of a flame or air acetylene or nitrous oxide acetylene flame. Set the instrument to zero against a reagent blank solution. Feed a standard or sample and optimize fuel oxidant or sample flow rates by adjusting fuel knob, fuel supports knob, and nebulizer so that a maximum signal is achieved. Prepare calibration curve by according observance of a series of working standards. The calibration must be done fresh for each set of sample. In case the instruments show a sign of a high or over error, dilute the sample depending on the absorbance of the sample and feed the sample again. If the instrument has been used in higher concentration range, uh, run distilled water until the reading returns to zero before closing down. Steps of switching off AAS. Turn off the gas supply from the cylinder first. Exciting Wait for a excitation of a flame and then turn off the fuel control knob. Turn off the or compressor and fuel support knob. The shutdown sequence of the nitrous oxide acetylene flame. involves first changing over the air acetylene flame and the exit exhausting it. Switch off the instrument. Precaution: acetylene cylinders should always be used in a vertical position to prevent a liquid acetone en- entering the gas line. Acetylene cylinder should not be turned pressure lower than 500 k poise 70 pies. Never operate acetylene line above 100 k poise. At higher pressure, acetylene can spontaneously it becomes decompose or exploit. Never run the nitrous oxide acetylene flame without a red uh, feather visible or with less than a 5 flow unit of acetylene. Do not leave uncovered containers of the violet or volatile organic solvent near the uncovered flame. Do not look the flame without the aid, aid of safety glasses or the flame shield. Do not leave the flame completely unattended. Do not ignite the flame if the airflow is below 7 flow or 6 flow unit. Do not adjust the air or nitrate oxide and gas supply to alter the sensitivity of the instrument after the calibrations of the instrument. A power backup is highly desirable for operating double AS, as a power failure leads to first conversion to a yellow flame, which is turn produce a lot of uh, carbon. Auto analyzer are extremely versatile and the modularized instrument used for a variety of chemical analysis of soil, plant, and water sample. This system are mainly two types: continuous of a flow analyzer and flow injections analyzer. CFA and FIA. These are designated to offer the automatic stimulation of operation used in a manual procedure for the estimation of an element on the conveyor belt principle. Normally, this same reagent which are used in is in a manual as say are used in the auto analyzer also. Principle in a auto analyzer based on the continuous flow analyzer. Mechanism: the samples are loaded into cups and test tube on the sample. The samples and a number of streams of reagent are made up of flow from one model. to the next through a plastic or glass tubings by a action of a multiple challenge and peristaltic pumps operating continuously. Each model automatically performs a different function in the analysis. Air bubbles are added to the flowing analytical streams to segment the streams of samples and reagents. Ferrier et al. 1980. Eight. The samples or reagent are the brought together under the control condition in the mixing qualities and that are part of the manifold causing a chemical reaction that produce color. The flow in injections all analysis system is similar to FCI in its model. However, there is no area segmentation. The sample is rapidly injected into the carrier stream by an injection uh, valve or sharing as a plug. Procedure read the operational steps mentioned in the manual provided by the manufacturer. Prepare a working standard of required concentrations, arrangements, and the carrier solution. Switch on the sampler analyzer and spectrophotometers and allow the list 30 minutes for warm up. Set the wavelength, gain factors, pump types, injections, and uh, valve cycle and the plotting parameters through a keyboard commands of the modules and per the requirement of the analysis. If the instrument is interfaced with the microprocessor, the above parameter may automatically be set by the default choose. Place blank working standards and samples in cups and test tube on a circular tray of auto sampler in a proper sequence. Place the carriers, the reagents, solutions bottle in the holders. Loosen the tube holders of the pumps and the inert the pump tubes. Except one contact aspiration in ends of all the pumps tubes to a bottle connecting degassed water digest, digested water. The press end of all the pump tube except one are concentrated to be manifold. Concept the aspiration and of the remaining pump tube with the injection valve outlet and the press its end to the vest tube. Attach the pump tube holders and the release the tension by turning the tension screw counterclockwise. Lubricated the pump tubes and the roller with the small amount of silicone oil. Assemble the manifold as per the requirement of the procedure and flow diagram and the instruction given in the application notes. The reaction equalized, and the tubes used for the various concentration should be strictly according to the prescribable color code to diameter in the application notes. Concept the inlet stream of the flow cell of the manifold and the out stream to the waste bottle. Check the flow pattern of a carrier streams by running the pump. Apply sufficient pressure on the pump tube holders by turning the tension screw clockwise until liquid starts falling through the pump tubes. In case of any leakage, stop the pump and correct it. After checking the flow pattern, remove the aspirations and the pump tube from digested water bottle and the connected it to the carrier and regent a solution bottle according to the requirement of the method. Now the instrument is ready for actual run. Start the pump and set the baseline 0 from the keyboard on the spectrophotometer by injecting the blank. Then run the instrument for a calibration and sample analysis. Draw a calibration curve by recording absorption from the display of the record of the series of a standard solution of increasing concentration from the uh, absorbations of the test solution. Find out the concentration from the calibration curve. In case of the microprocessor in interfaced instrument, the sample picks are the automatically compared to the calibration curve after being corrected for a baseline and the sensitivity drift and the result and display on the monitor screen. In case the instrument shows sign of over an error, appropriately dilute the sample considering the observed observations of the sample and feed the dilute sample. Switching off the auto analyzer before closing down. Operate the instrument using distilled water and from all the channels unit the detector reading returns to zero. Loosen the pump tube holders immediately after the analysis. Switch off the instrument in the following order: spectrophotometer, analyzer, and sampler and computer. Precautions: never use any component of the instrument if it is in need of the adjustment and or a repair. Always keep the equipment clean. It is important to clean the sampler and manifold immediately after the analysis is over. Clean the roller and the pump tube holders and the lubricated this with the silicone oil regularly. Replace the replace the flatteneds and the dirty pumps tubes periodically while using new pumps. Tube care should be taken for the change of flow rate. Use all the tubing of the prescribed diameter or color could as given in the application notes. Check all the tubings before use for the collagings of the passes. maintains different manifold units for a different analytical method to avoid a sample contamination. Use solvent resistance manifold for a organic solvent. Never use a organic solvent on a plexiglass manifold, not even for a cleaning for strand. Regularly check the manifold bores for a plugging. Use nylon or a wire steel to remove solid particles. It is important that the external walls for of the flow cell are kept absolutely clean. Fingerprints, glasses, etc. can be removed. Only tissue paper is soaked with the acetone or absolute ethanol. Care should be taken in handling cadmium during a column preparation, as it is a toxic. So here completed about some basic information about spectrophotometer, flame photometer, auto analyzer, double AS. Next week we will see ICP and AES.